Okay, so this is the last part of chapter 8. We are doing connected objects where we have linear motion and also we have rotational motion. So last time in chapter 3, we learned about free body diagrams, right? And we learned that for a pulley system, okay, and later, ABC to later. Okay, so we have two masses. This guy has M1G, distractednya aku. And this guy has M2G. And we know that since it is connected to a string, it has tension as well. So this guy is T1, this guy is T2. And I told you if in chapter 3, we could ignore this, we just assume that T1 is equal to T2. Okay, we just assume that T1 is equal to T2 in chapter 3. Here, we are doing the rotation. Oh yes, open. Here we are doing the rotational motion, whereby if we have tension over here, okay, let's just look at one tension. If we have tension over here, and the torque is RF, right? Torque is RF, where R is the length from the axis of rotation to the force, and force must be perpendicular to whatever that you're doing. So here, your R is this, and this is your T. So this gives you the RF, because tension is also a force. So this is your torque now. This gives you the rotational motion clockwise. So this gives you the rotational motion clockwise. Okay. Okay, so yang tu saya nak cerita pasal torque je dulu. Okay, now going back to the free body diagram, we have acceleration going up, acceleration going down, A1 and A2. Now, is A1 equal to A2? Is it equal or is it not?
Yes, equal.
Yes.
Why is it equal?
Yes. Sebab tali yang sama.
Because it's the same tali, betul?
Because they move simultaneously.
Yes, connected. They move simultaneously. Correct. Everyone is correct on this one. Good. So you've learned this before, and you know that acceleration 1 is equal to acceleration 2, which means that the pulley also rotates at the, is it the same acceleration?
Yes.
Yes, it rotates at the same acceleration, but this time it is AR omega. So the pulley rotates at alpha. If you want to find the linear acceleration, you should times it with the radius, and the radius is this guy over here. So again, I'm going to repeat myself. This guy, A1, is equal to A2. This guy has the same acceleration, but it is rotational. So how is it all connected together? It is connected together by this equation. So they are all having the same acceleration, except that the pulley is rotational. So what you should do is you multiply, you use the A divided it by the radius, you will get the angular acceleration of the pulley. Okay. So this is the free body diagram. This is the free body diagram. It's linear. This guy is the free body diagram for the rotational part. So here you can draw your radius like this and your tension like this. You can do that. If you want it to be more clear for yourself, you can say R is this way, because that is R also. So R is perpendicular to the force, which gives you torque. All right. Now that we know what this free body diagram looks like for a system like this, let's do this free body diagram, the other free body diagram. So we have two boxes that is connected to a pulley system. Let's draw it. So I'm going to use my orange. So here I have the center of mass. I have mg. The answer is on the right, but let's do it together anyways. So the motion is this way, right? So my free body diagram should have a friction in this way, in the opposite direction, which is to the left. And since the box is on top of a surface, it will have reaction force. right? And this guy is connected to a string, so it will have tension. Tension always points towards the center of the string. This is the center, so it points towards the center. This is my pulley system. I also have tension. So if this is T1, this is also T1. If this is T2, this is also T2. Okay, and this guy is mg. This box does not have no R, no friction. Both of these are contact forces whereby you need to have a surface to have these two forces, reaction and friction. So since it is in mid-air, it's tergantung, right? So you don't have R, you don't have friction. Contact forces. Sorry. Okay. Okay, so that is that. Next one. So free body diagram, linear plus rotational, sama juga. So we have angle over here. This is my mg, and we've learned this before. Our mg can be resolved. In this direction, it becomes mg sine theta. In this direction, it becomes mg cosine theta. Right? We have a string, which means that we have tension 1. This guy is tension 2. Sorry, tension 1, tension 2, tension 2, and mg. It's the same thing, except that it's on an incline. So you have to resolve the mg. Okay, and also you have rotational alpha here. And how do you know it? The radius is always perpendicular to the force. So you will always have torque. So there is rotational motion. Here, your rotational motion is going this way. It is going anti-clockwise, which means that your motion is going this way. There is your motion. Oh, I forgot to mention on the other example. Let's look at it. Atas. Okay. So this guy, dia rotate macam ni. It's going clockwise, which means that your motion is this way. So that is your A here. And this is your A over here, going this way. Motion is going downwards lah, basically going to the right and going downwards because your pulley is rotating clockwise. Okay, so let's go over the problem solving strategy. Read and understand the question, visualize and sketch. Identify the rigid body. Is it in equilibrium or does it have acceleration? Identify all forces acting on the body. When the object is in contact with the surface, it will have either reaction or frictional depending on the situation. And if it is connected to a string or a rope, it will have tension. And the body will always have weight. Okay? There's nothing. Ada tak benda yang tak ada weight? Tak ada. Identify the axis of rotation. You know this. You can make your own axis or you can use the conventional axis. Calculate the torque for each force. Apply the relevant rotational dynamics equation. Substitute known values, calculate the unknown, and state your final answer with the correct units. Okay, please do not forget units. Apa ni? Kenapa 2 kali ni? Okay, so this is the condition. If it is moving, so this is net in the F parallel or net in the Fx, or depending on which one is parallel, which one is not. So sometimes your Fx is equal to MA, sometimes your Fy equals to MA. We saw that in the pulley system, the box, sorry, tak ada arrow macam tu. In the pulley system, for this particular box, mass 2, our Fy had minus MA for this guy, right? This guy has Fy equals to minus MA, but the Fx is equal to 0. For this guy, mass 1, this is mass 1, this is mass 2, the Fx is equal to positive MA, but the Fy is equal to 0. So it depends which one you are looking at. The equation for each free body diagram are different, right? And for this particular guy, you choose the torque equation. If it is rotating, you know that you have I alpha. Okay, net torque is equal to I alpha. This is your condition if you have rotational motion. Sama juga macam kita cakap MA. If it is rotating, we have I alpha. If it is not rotating, we have the condition of net torque equals to 0. After you write your condition, you write what is in your free body diagram into the equation. So here, you have T2, you have T1 here. So let's just take T2 over here. Assuming T1 is equal to T2 lah. Let's just say both of them are T. Kejap, kenapa pula ada recovery ni? Okay, let me use a different color for that. Okay, let's just talk about T first. So this is T. Oh. So this is T and I have R, right? So my equation becomes R T, because T is a force, R is the length of the force to the axis of rotation. It is going clockwise, so it is a negative. So condition, check. Write the equation in the that is in the free body diagram, check. So that is how you solve it. Okay, apply the relevant linear rotation motion relationship if you need to. Connect the linear acceleration to the angular. And we have discussed this before. Your pulley should have the same linear acceleration, but it is rotating. So you just multiply it with the A divided by R to get the angular acceleration. Okay, so let's do this example really quickly. Can I give everyone 10 minutes to read and try to write the equation? Write the condition, you draw your free body diagram, write the condition, write the equation. You don't have to solve it, just write the equation in the free body diagram is what I want you to do. 10 minutes, so I'll come back at 11:28. Let's do this one. This is the last problem. Okay, if you get this, you basically get the entire chapter 8, I think. Okay, 11:28, okay. I'm gonna call someone to help me as usual. You can ask me if you have any questions, okay? What's the bird? 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 Mommy, what's the bird? Okay, so I'm back. Did you guys get it? Okay, so I'm gonna ask Humaira for the bucket punya free body diagram. Sekejap nanti hantar gambar dekat WhatsApp. Kita tengok sama-sama. I wanted to draw. Kejap Humaira, the bucket, and Ridwan is the pulley. Okay, so Humaira, bucket, free body diagram. Bucket. Dia hantar kat WhatsApp punya group. Ridwan, free body diagram, pulley. Okay. Nick Nor Adlina, bucket punya equation and condition. Condition plus equation seorang lagi. Shazwina. Did I pronounce that right? Sekejap, tengok balik nama. Shazwina ke Shazwina? Shazwina ke Shazwina? Sekejap, tengok balik nama. Saya selalu tertukar. Okay, Shazwina. Sorry, Shazwina. Shazwina, free body diagram, equation, pulley, the condition and the equation. Okay, so hantar dekat WhatsApp, kita tengok sama-sama. It's waiting. Okay, Humaira, can you label the acceleration as well? Dah betul dah, cuma saya nak tahu acceleration awak arah mana. To make the free body diagram complete.
What's this one?
Janganlah.
What's one?
Wow. Wow.
One.
Sekejap, Mami nak tengok. Okay, thank you Myra. Ridwan punya free body diagram. Hey. Oh. Ridwan punya, kejap. Ya Allah, Ridwan, cair ni awak pensel. Jangan kacau Mami. R is 0.6 and T. Okay, betul. Okay, equation Nick Nor Adlina dengan Shazwina, please. Can you write that down?
Okay.
Okay, so torque is I alpha. That's the condition, betul. And the that is 1/2 mr squared alpha. RF is equal to 1/2 mr squared A over R. Okay, so jap. Dalam Shazwina, RF tu, F tu F apa? What force is that? Kena tulis F apa?
FT doctor, sorry.
Apa dia?
The tension.
Tension kan? Okay. Can you correct that? And delete balik yang ni supaya orang lain boleh refer nanti. Okay, thank you Shazwina. Ini Nick Nur Alina, T equals to minus mg bucket equation. Okay, T minus okay, T equals to M1G plus M1A.
Mommy.
No, I cannot help you. Thank you, Shazwina. Got it. Excuse me. She is. Kejap. So bucket, bucket Nick Nur Adlina ni acceleration dia going down. Okay, Nick Nur Adlina punya equation sikit lagi nak betul. Cuba tengok balik. Your acceleration is going down. So tengok balik equation tu. Yang lain dah betul. So let me write that here. Okay, I'm surprised everyone, I mean orang-orang yang saya tak suruh ni dapat betul Okay, Nick Nur Adlina sikit lagi untuk dapat betul. Please correct that. Sekejap saya nak letak dekat dalam Word.
Doctor, the
Yeah.
acceleration, is it negative?
Yes. If you decide going down is negative, then it's negative lah because you said minus M1G, M1G is minus, right? Because so going down is negative. So if acceleration is going down, it should also be negative, right? Itulah balik That's why I always start with condition supaya tak confuse. Okay. Yep, betul. T minus mg, yep, T minus m2g equals to minus ma. Okay, betul. Thank you. Okay, so let me write that down for everyone else. Where's my pen? Whoopsie, so huge. Okay, so let's do that together. So kita tengok Ridwan punya jawapan. He wrote it like this. Okay, so this is his diagram. And he said tension is here, T1, and this guy is T2. Sorry, this is T2, this is T1. Okay, so that's the free body diagram. And then the bucket,
Doktor,
rotation tak ada kat sini. Yep.
doktor tengah buka words ke?
Sorry, saya tak share. Sorry, forgot. Thank you for letting me know. Okay. So kat sini sepatutnya lah kalau nak lagi complete, Ridwan should have labeled the angular acceleration punya direction clockwise. So this is the one missing Whoopsie. Okay, so and then Humaira drew the bucket punya free body diagram. Allah, kenapa tak boleh detect lagi? Hello. Okay, give me a minute. Hello, kenapa dia tak boleh ni? Sekejap. I need to figure it out. Let's see. Okay. This is mg. And Humaira said this is T. Okay, so since this T2, this is T2 as well. And then we have acceleration going down here. Kat sini going down, kat sini ada clockwise. Okay, ni clockwise. This is going down. Okay, lepas tu equation Shazwina, which was excellent. Net torque is equal to I alpha. We start with the condition. The condition is I alpha because it has rotation, it has acceleration, it has angular acceleration. And what is in your equation? You have R as the radius and you also have T2, right? So the basic equation for torque is RF, right? So RF, the R is the radius. Let's just use capital R here. And the F here is T2. Okay, so I alpha equals to RT2. Okay, and we know that I, the moment of inertia for a cylinder, this is a cylinder, and that is 1/2 mr squared. Okay, so first I'm going to equate these two together, T2, right? And this one becomes 1/2 mr squared, sorry, alpha. This becomes alpha. Oops. Hey. And okay, this is alpha. This is R and this is T2. Okay, and Shazina also substituted alpha as A over R, 1/2 mr squared, A over R, so that she can use this torque equation into the force equation later.
I can help me.
Okay, no, I cannot help you. Kejap, And then RT2. So what I can do here, I can put the R, I can just bawa R to the other side, right? So it becomes 1/2 mr squared. Here, Yusuf, this one. Here you go. Okay. Okay, you go outside, okay, and then close the door. Close the door. So it becomes R squared equals to T2. So this cancels out. So you get T2 as 1/2 MA. Okay. So tu daripada equation Shazwina. And then equation Nick Nor Adlina pula. I need a new space. Sekejap. How do I do that? Alamak, stop lah aku kat atas ni. And then we have our net. We start with the condition. With our condition, F net y equals to MA, and our bucket punya free body diagram, MG, and then T2 up here, A going down. If I want to say going down is negative, I can do that. If I want to say going down is positive, pun boleh. But here, but Nick Norlina said her MG is a negative. So it means that her going down is negative. So she's the one who decided that. So this MA becomes negative as well. So dia cakap tadi MG ni negatif. So MA pun kena negatif lah because A is going down. Then you write down your equation from the free body diagram. So MG is going down, T2 is going up. So your equation becomes minus MA equals to minus MG plus T2. Now remember, these two masses are different. Ni mass untuk bucket, yang tadi tu mass untuk pulley. So the mass for the bucket, let's say it's mass 2 lah. So we will say it is mass 2, mass 2. Mass yang pulley tadi tu kita panggil mass 1 So this becomes mass 1. Okay, and then this is the acceleration. The acceleration is the same, right? Because we are all connected together. Our acceleration should be the same. So I have this equation. I'm going to bring it to the force. T2 equals to 1/2 M1A. T2 equals to 1/2 M1A. Okay, mass 1 and mass 2 are different. So you have to be particular on this one. So here I have T2. I also have T2 here. So let's rearrange this to solve for T2. So T2 becomes M2G minus M2A, right? So this becomes, I'm going to substitute T2 into this guy into the second equation here. So M2G minus M2A equals to 1/2 M1A. The A should be the same, right? Because they are all connected. So ni bukan A1, ni bukan A2. It's just the same A. So just A je lah. So 1 over 2 M1A plus M2A equals to M2G. Now I'm going to factor out A so that I can solve for A. So 1 over 2 M1 plus M2 equals to M2G. Now I can solve for A equals to M2G over 1 over 2 M1 plus M2. Okay, so that is your acceleration. Let me see if I did this correctly. Okay, betul. So I know what M2 is. Let's see the equation balik. The equation, dia punya soalan. M2 is the bucket. M2 is the bucket. M2 is the bucket. The bucket is 3 kilogram. The pulley is 5 kilogram. So M1 is 5. M2 is 3. Okay, M1 is 5. M2 is 3. So just substitute that. 9.81. 1 over 2. M1 is, sorry, it's not like that. M1 is 5 plus 3. Okay, so the answer is A equals to
5.35.
Okay, thank you. 5.35. Now, the answer is not complete. Acceleration is a vector. I have to give the direction, right? So the direction is, we labeled this here. And from our assumption, our A is going down, right? This is our assumption. A, assumption. And then kita punya jawapan positif. Maksudnya, our assumption is correct. If our assumption is not correct, this answer will be negative, which means that the acceleration is going up. So my final answer would be A is 5.35 meter per second going down. Or you can just say, you can just put the arrow going down. Okay, so that's your final answer. This one. Okay, so into acceleration, soalan dia apa lagi? What is the linear acceleration? So we got that, A. What is the angular acceleration? And we all know that acceleration is connected to the angular one because they are all the same thing. So A equals to R alpha. R is 0.6. And you know what your A is, 5.35. So you can solve for your alpha. So alpha is 8.92 radians per second squared. And alpha is also a vector, which means that you have to give the direction. And we assume that it was going clockwise. The answer is positive, so our assumption is correct. So we stick with clockwise. Okay, apa lagi? The next soalan dia cakap, what is the tension of the string? Okay, part ni dah jadi substitute je lah. We already know that T2 is equal to 1 over 2 M1 squared. M1 is 5 and A is 5. A is 5.35. Okay, so just substitute je lah. Okay, so the answer for that will be tension 2 is equal to, did I calculate it? Yes, I did. It's 13.4 and the unit is a type of force, so it's a Newton. Okay, so that is your answer for T2. For C, tension is 13.4 newtons. How far does the bucket drop? Okay, so how do we solve for D? How do we solve for D? Anyone wants to try?
S sama dengan UT
UT plus
dah 1/2 AT kuasa 2.
Correct. So we already know what A is 5.35. We know what T is, it's 4. And our U, it starts from rest, so this is a 0. So S is just 1 over 2, 5.35. Sorry. times 4 squared. Okay, so your S answer is 42.8 meters. Okay, and dia cakap how far does the bucket drop? So dia dah bagi tahu dah it's going down, right? So if you want, you can just say leave the answer as it is 42.8, or you can say 42.8 downwards. Boleh juga. But the question already said drop. So kita dah tahu dah lah they're going downwards anyway. But to be safe, just write it. Okay? But you don't have to. But I will encourage you to write it. Okay? Okay, so this is the final problem for chapter 8. So we are going to do chapter 9 now. Let's have 5-minute break. Okay, before we start chapter 9, I'm going to stop recording. So I have 2 recordings nanti. Stop. Okay, 5 minutes, come back, 11:52.
Doctor.
Yep.
I have a question, but I'm afraid that I will confuse others.
Okay, let's hear it. Apa dia?
From the equation that Shazvina sent,
Shazwina, kejap. Huh?
isn't that the reel is moving in clockwise? So why not that RT shouldn't be in negative?
Oh, you're right. Kejap. Let me think about that one. It's a negative RF. Betul. Kejap. What did I do for this one? Yeah, thank you, Kak Dylan.
You're welcome, doctor.
Saya dah tak payah tengok nama dah. Saya dah tahu dah suara korang macam mana. I'm proud of myself. Okay, jap What was that? So clockwise. Kejap This one is a negative. Betul. Kenapa jawapan saya sama? Kejap. I will get back on that one. Pasal direction dia. Betul. Kabilan is correct. Shouldn't we put the negative sign? Betul. Kalau saya letak
Okay, doctor. Thank you, doctor.
Okay. Negative sign. Yep.
How about when we use the tag R equals T equals to RS and then the force is the tension, so it is on upward.
Mason, sorry lagi sekali.
When can we consider that the force, because just now we used to start in the equation, we use the tension. So actually the tension is pointing upward, so the direction should be anti-clockwise.
If you assume
when we start the equation inside the total equation, we use the tension. So the tension is pointing upward. So can we consider that it is positive because upward is anti-clockwise?
Oh yes, if it's going upwards then you can say it's anti-clockwise. Tapi jawapan akhir dia is clockwise tau.
Oh.
So kat sini ada error kejap. Apa yang saya tertinggal lah kat sini?
Doktor, saya buat yang ke bawah negatif pun saya dapat acceleration dia positif.
Oh, but acceleration dia ke bawah negatif. Oh, okay, I know what it is. Okay, my bad. Okay, so tadi kita cakap equation Shazwina macam ni. Mana tadi? Torque. Where's torque? Okay, it's down here, forgot. Okay, so I said I alpha and RT2. So Kabilan said, kenapa kita tak negatif? Sebab yang ni kan going clockwise. Okay, betul. This is our negative. But this guy is also going clockwise, right? It's also going clockwise. Kita assume dia clockwise. So this is also a negative. So negative dengan negatif, positif. Tu je lah. Betul, Kabilan is right, but we missed out the direction of I alpha as well. Okay, so I alpha positive, RT.
Oh, doctor, so the net force could be in negative.
Yes, boleh. Macam kita punya
Thank you,
MA.
doctor.
MA kita pun ada positif, ada negatif kan? Boleh juga. So clockwise negative, anti-clockwise positive. Okay, hope that's clear. Okay, so let's take 3 minutes to go. So before I start chapter 9, saya nak wrap up kejap recording ni. I'll see you in 3 minutes. Stop this recording. Stop recording.